Namaskar. In continuation of convection, I would like to introduce the boundary layer concept. Boundary layer BL is, we are going to use symbol BL for boundary layer. And before the start of this topic, which is a boundary layer formation, there is an introductory part which we have to cover. The first one is what are the various types of flow. There are basically two types of flow. First one is the external flow, second is the internal flow. When the fluid is flowing over the solid cylinder, over a solid body, then the flow is called external flow. When the fluid is flowing through the tubes or through the duct, then the flow is called internal flow. There is a formation of boundary layer in case of external flow and also in case of internal flow. First, we have to understand what is the meaning of free stream region. There is a region which is known as free stream region. Consider the case of a flat plate. Let's say it's a flat plate which is fixed. Over the flat plate, a fluid is flowing with some velocity, and we know there is a formation of boundary layer near the surface of this flat plate. In case of external flow, the boundary layer develops freely without any constraint. Boundary layer develops freely without any constraint, and accordingly the region of the flow outside the boundary layer in which the velocity and temperature gradients are negligible, means this region where the temperature and velocity gradients are negligible is known as free stream region. Free stream region. It is outside the boundary layer. When the fluid flows over the surface, it divides the total region into the two regions. First one is the region which is below this line, which is a boundary layer line, and there is a second region which is above this line. The region which is above this line is known as free stream region, and here the effects, what we are going to say, the velocity effect and temperature effects are negligible. As there is a fluid is flowing over a solid body or over a flat plate, then due to this there will be a, which is known as a external flow, and the heat transfer process in between the surface and the fluid is called external flow convection. Here the convection will be external flow convection. External flow convection. Now the relative motion in between the plate and the fluid is maintained with the help of some external energy, the energy which is given by the pump, or we can say some other means. This fluid is flowing over the flat plate. Now we are interested in this chapter, our primary objective will be to determine the heat transfer coefficient. We know Newton cooling law, HA delta T. Here H, which is a convective heat transfer coefficient, our primary objective is to determine the heat transfer coefficient. Heat transfer coefficient. And because there is a motion of the fluid which is flowing over a body, over a plate, due to that there is a second part which is also very important. We are also interested to find the coefficient of friction. There is a second part which is known as coefficient of friction. These are the two important factors we are going to determine for this chapter, or we are interested to find the coefficient of friction and coefficient heat transfer coefficient. The symbol for heat transfer coefficient is H, and the symbol for coefficient of friction will be, it will be CF. Coefficient of friction will be CF. When the fluid is flowing over the solid body, like this case, the fluid is flowing over the solid body, it is responsible for drag, lift and cooling or there may be a heating. If the fluid is stationary and the solid body is immersed in it, it will exert only pressure forces. But when the fluid is flowing over the solid body, then there are two types of forces. First one is the pressure force, second is the shear force. Both forces will have their components. One component will be along the flow direction and the second component will be perpendicular to the flow direction, or you can say normal to the flow. Both forces, pressure forces, will have two components. Shear forces will also have two components. For drag and lift, for the case of drag is a force which is along the direction of the flow. When the fluid is flowing over the body, the force which is acting along the direction of the flow is known as drag. Now, the component of pressure force and shear force along the direction of flow will contribute for the drag, and there is a second force which is known as lift. Lift will be exerted by the fluid due to the pressure and shear forces, and components which are responsible for the lift are normal component forces which are acting normal to the flow of pressure and shear forces. We know there, when we are considering the fluid flowing over the flat plate, there is one more important velocity, we can say name given to the velocity, which is known as free stream velocity. The velocity which is far away from the surface, where the effects are negligible, temperature and velocity effects are negligible, that is known as free stream velocity. And there is a one more velocity, that velocity is known as approach velocity, or it is also called upstream velocity. Upstream velocity is the velocity with which the fluid is coming towards the surface, towards the body. For assumption, it is assumed that this velocity which is approaching, which is known as approaching velocity, which is approaching towards the solid surface or a plate, for that case this velocity is uniform and steady. Next we can I want to again define convection. We also know one definition of convection, which is it is the mode of heat transfer in which heat is transferred due to the heat carrying capacity of the molecule from one place to another place. Consider this example. Suppose it's a wall. It is at a temperature Ts. There is a fluid on the right hand side. Its temperature, let's say it is Tf. If Ts is greater than Tf, heat will transfer from the surface to the fluid. If the fluid is moving with some velocity, then there will be a formation of boundary layer over the surface. Now I want to define convection again in terms of advection and diffusion. What are these two terms? Convection involves two phenomena. There is a bulk fluid motion and it is called advection, and at the same time there is a random motion of the fluid molecule, that is called diffusion. Next, we are going to understand boundary layer and boundary layer formation. But boundary layers are of three types. There is a velocity boundary layer, which is due to the change of velocity. There is a thermal boundary layer, which is due to the temperature difference. And third one, there is also a concentration boundary layer, which is due to change of concentration. This topic is covered in mass transfer. Concentration boundary layer topic is covered in mass transfer. There are three important factors which we are interested to find the value for various different geometries. First one is the Cf, which is the coefficient of friction, which is very important for boundary layer formation. There is a convective heat transfer coefficient. When there is a transfer of heat from surface to fluid during the boundary layer, this H is very important. Similarly, for the case of mass transfer, there is one coefficient which is known as diffusion coefficient. Next, there is one more important term. That term is a film temperature. To understand what is film temperature, we know when we have considered the case of boundary layer formation over the flat plate, as the case of when the fluid is flowing over the flat plate, there is a formation of boundary layer near the surface of the solid body or a flat plate. I'm going to draw this diagram again to understand what is film temperature. Consider a flat plate. Let's say it is fixed. There is a fluid moving over it with some velocity. We know there is a formation of a boundary layer over the surface. Film temperature is the temperature which is, we can say it is the arithmetic average of the surface and the free stream temperature. This surface have some temperature, let's say Ts. There is a temperature which is known as free stream temperature. There is one more term which is known as free stream temperature. Free stream temperature is the temperature of free stream, the fluid which is not affected by the presence of this body. The temperature which is far away from the surface is known as free stream temperature. Let's say it is represented by T alpha, T infinity. Now, film temperature, which is represented by, let's say, Tf is the film temperature, is the arithmetic average of the surface temperature and free stream temperature. Surface temperature and free stream temperature divided by 2 is known as film temperature. This temperature is important. Why? Because when we are moving along the y direction from the surface, along the y direction, there is a change of temperature. At the surface, there is a surface temperature and it is approaching towards the T infinity. There is a variation of temperature from point to point along the y direction. For the calculation point of view, we need a one temperature, and that temperature is known as film temperature, and we will note down the various properties of the fluid at film temperature. It is very important temperature because we are going to note down the various properties of the fluid like density, viscosity, specific heat from the table at film temperature. Again, draw a flat plate. It is another view of a flat plate. Fluid is flowing over it. Practically, the value of heat transfer coefficient H and Cf, heat transfer coefficient and friction coefficient, it is different at various locations. It is its value is different at different location. But what is known as average value of heat transfer coefficient and friction coefficient? This value, which is known as the average friction and convection coefficient, it is calculated by integration method. So let's say we want to calculate H, average value of heat transfer coefficient H. It will be equal to 1 by L integration from 0 to L Hx and dx, where Hx is the local value at distance x on the plate. X is the distance, which is x is the axis, which is we are going to consider x-axis. This is the y-axis. Along the x-axis at distance x, there is a value of heat transfer coefficient that is known as local heat transfer coefficient. When we will integrate this local heat transfer coefficient over the entire length from 0 to L, that is known as average value of heat transfer coefficient. Next, to understand the boundary layer concept, there is a laminar and turbulent regions. Consider again the case of flat plate. Over the flat plate, fluid is flowing with the velocity of approach, or which is also known as upstream velocity, and it is uniform and steady at the leading edge. When it flows over the surface, there is a formation of a boundary layer from the leading edge to some distance. From the leading edge to some distance, and the fluid flow inside the boundary layer, it remains laminar. Where the fluid flow remain laminar, that region is known as laminar region. This region is known as laminar region. If if the plate is sufficiently long, fluid will flow over it, and after some time and after some distance, the fluid flow inside the boundary layer will become turbulent. It will become turbulent. The fluid here, after some distance, it will become turbulent, and the region where the fluid is not laminar, it is turbulent, is called turbulent region. The transition from laminar to turbulent, it depends upon various factors like surface roughness, upstream velocity, surface temperature, etc. But the Reynolds number is very important. The Reynolds number at some distance, let's say at some distance x, the Reynolds number value, we know it is Re will be equal to rho v L divided by mu. We can say this L is x, at distance x the Reynolds number. But the fluid flow over a flat plate, the transition from laminar to turbulent begins at some value of x and Re, and that x is known as xcr, which is a critical distance. And at this critical distance there will be a value of Reynolds number. That Reynolds number, which is known as Reynolds critical, it is known as critical Reynolds number. Its value, critical Reynolds number's value is 1 into 10 to the power 5 for the case of flat plate. We know there are local values and average value of heat transfer coefficient and friction coefficient. Over the flat plate, at a particular location, at a particular distance x, the value of heat transfer coefficient is known as local value of heat transfer coefficient, and that local value is represented by hx. Average value is represented by h. We know this. Now, for the laminar region and the turbulent region, we are interested to find the value of heat transfer coefficient or Nusselt number, because Nusselt number is having h, which is the convective heat transfer coefficient. Nusselt number is equal to HL by K. When the fluid is laminar, when the fluid flow is laminar, it is determined with the help of Reynolds number. Reynolds number is calculated. We have to check whether the Reynolds number's value is greater than 5.5 into 10 to the power 5 or whether it is less than this value. For the case of a flat plate, when the fluid is flowing over it, if the fluid is laminar, the flow is laminar, and the value of Reynolds number is greater than 5 into 10 to the power 5, we will use this equation to calculate the value of heat transfer coefficient H, which is in the form of Reynolds number and Prandtl number. And if the flow is turbulent, we will use another equation, empirical correlation of Nusselt number, which is also in the form of Reynolds number and Prandtl number. Again, we have to check the value of Reynolds number and Prandtl number. There is a range for this. How to use this equation? We have to check the value of Reynolds number and Prandtl number first, whether it is in this range or not. Now, what about the heat transfer coefficient H and friction coefficient CF? Heat transfer coefficient H, it first decreases from the leading edge to the region up to the region, laminar region. The heat transfer coefficient first decreases, then its value increases in the turbulent region. Heat transfer is more when the fluid flow is turbulent. In case of laminar region, when the fluid flow is laminar, the heat transfer coefficient is less.